Hello folks, and thank you for watching this video about SAT or Service Activation Test. My name is Ilyas Azar, Senior Solution Architect for EMEA region. In this video, we're gonna discuss the RFC 2544 and its rival, the Y1564. Also share you some best practices for each test, and also share you a use case which we encountered in the field that shows the big value of having a SAT test during the operations. So basically, we're gonna go over the SAT itself, why it's really needed nowadays. Then we're gonna move to the RFC 2544 and then to its rival Y1564. Then make a quick comparison and conclusion between both. And then we're gonna shed more light on Accedian flavor of the SAT. And then share you the use case which we encountered in the field, which really shows the value of SAT. So, what is SAT and why it's really needed? So, SAT or Service Activation Testing is an automatic traffic generation test which aims to validate the conformance of the connection or a service against its desired design or against its committed SLAs. The need for SAT is increasing rapidly due to the mounting complexity of the networks and the networks model that are carrying multiple services across shared path. Every service has its own KPIs, and the network should be able to honor those various services and thresholds. That's why we need tests to verify that. So to guarantee a flawless connection delivery, SAT should be executed before handing over the links. After SAT is executed, a report is generated, which we call the birth certificate report. So basically, the old way of provisioning and delivering the service will lead to no satisfaction, while the better way to do is provisioning, executing a SAT, getting this report, and then this is the recipe for satisfaction. So the two main industry SAT methods are the RFC 2544 and its rival, the Y1564. Each test aims to verify the conformance of the connection from a different perspective. While RFC focuses on the performance of every packet size against the intended bandwidth, the Y1564 focuses on the CIR-EIR perspective of every service among the multi-services medium. More details about each test is during the course of this video. So why SAT is really needed? After engaging with hundreds of customers, we saw that the majority of the customers do not properly use SAT as part of their service delivery, and of course, they suffer the consequences later. So why those customers do not use SAT? Some just try to save time. Some just need proper awareness about SAT and its value. Some does the SAT, but neither properly nor sufficiently. So below are the category of customers that do not use SAT. Some operators only provision and deliver. They just take a leap of faith and do not do any end-to-end validation nor bandwidth testing. So it's just a matter of connectivity and reachability. Of course, it's not good enough. Other more advanced operators provision the connection, test for reachability, push some traffic to test bandwidth. However, the methods they use are neither efficient nor reliable, such as high density pings or just a tester with a terminal loopback. But this is not good enough because those methods still miss many hidden network flows that will cause problems after delivery. Some operators perform SAT but improperly, such as using RFC 2544, where they should be using Y1564 or vice versa. We're gonna come to that and the difference and the similarities of both tests during the course of the video. And the minority are the correct operators that conduct RFC 2544 testing and Y1564 testing at the right time, right place, especially in their complex connections across multiple vendors, multiple class of services. Those are the correct and those are the minorities, unfortunately. We need to make everyone correct. So what are those operators missing by not using the SAT? Throughout our engagements with the customers, we found many problems inflicting them and causing them losses and churn and time, all which simply could have been avoided had they used RFC 2544 or Y1564 properly and sufficiently. And here are some examples and use cases. Many operators do not realize that not every packet size can achieve the desired data rate or bandwidth. So thanks to the RFC 2544, which validates bandwidth per every packet size and thus uncover this potential flow in the network. Many operators also test every class of service independently, but after the link is delivered to the live network, the problems start to show. thanks to Y1564, which can test the HQS by pushing multiple flows or class of services simultaneously and confirm whether the bandwidth hierarchy is working as expected or not. So testing each service separately is one thing, and testing them all together is something else. Some operators provision and deliver the services after basic testing. However, they miss the fact that there is a VLAN mismatch or a P-bit mismatch or a DSCP mismatch between the endpoints, which will cause disruption of the critical services as their cost is wrongly mapped to a different value. Thanks to the end-to-end cost validation in the Y1564, which will help uncover this potential flaw in the network. Also, some operators discover bottlenecks in their service before handing over. However, they fail to easily pinpoint the direction. Y1564 came for the rescue as it supports single direction, A to B versus B to A, so you can easily spot the bottleneck direction. Also, many operators test their traffic to their desired bandwidth. However, they miss the fact that not every packet size is within the acceptable delay and delay variation. So maybe smaller packets are complying, but larger packets are not, or vice versa. So the operators really fail to comply with various delivered services because there is a hidden flaw that they cannot find. RFC is the best tool and the best test to confirm that every packet size at the maximum tested rate is still within the acceptable KPIs. So given all the problems and all the scenarios where operators are missing the flows in their network, there is a big opportunity to upsell SAT so that we can help them pinpoint the problem before delivering their services. Okay, so in general, that's SAT and why we needed SAT. Now, what is RFC 2544 and what's the significance of RFC 2544? RFC 2544 is the most commonly used test. This test was originally introduced to test the hardware performance. However, it proved to be a very useful method to test connected hardware or simply network links. So it used to be hardware, now it's to test for networks. The RFC 2544 test focuses on the bandwidth capabilities of the given link. It injects traffic from a user-defined minimum with a user-defined step size all the way to the maximum CIR or bandwidth to be tested. The test tries for all packet sizes at all rates and generates a report. The success and failure criteria of the RFC test is strictly related to the packet loss only, although the test report display other guiding results such as delay and delay variation per packet size, but those are not acceptance criteria. The test consists of 4 blocks and each block has a specific purpose to focus on. The 4 blocks are optionally selected by the user. They can choose to keep or remove one of the blocks. Every block has its own parameters for the setup. And as a result of the RFC 2544 testing, a report will be generated, which is the birth certificate report, and it consists of the 4 blocks with 4 different kinds of information. For example, block 1. Block 1, this block displays for all the given packet sizes the maximum successful reach rate. This block is very important confirmation that all packet sizes, including the jumbo, can reach the desired threshold. It is known that smaller packets cause higher CPU load for processing on the network elements, and as a result, not all hardware or firmware perform well for small packets under high rates, thus leading to a failure of reaching the desired bandwidth. So this is a hidden flaw. Sometimes you feel there is a bandwidth being reached or not. This part or this block of the test will uncover this flaw. Block 2, which is delay focused or delay and delay variation. This is also a very important block which provides delay and delay variation for all the successful iterations of the upper or previous block. This is a very important block since most of the operators focus on utilization and miss their delay and delay variation budgets for all packet sizes. So this will focus on the delay and delay variation if they are still within the specs for all the packet sizes. This is not a success criteria for the report, but it's a very useful part in the test. Third block, which is the frame loss. This is mainly a repetition of the first block, but checking for the last 2 successful rates, the max reach and the max reach minus the step size. This is a useful block. It's considered as a reassurance block for operators that are running the test for a very short time. So to make sure this is not an accidental success at the maximum rate, we use the maximum rate and go back maximum minus step size. The fourth block This block is the test where we generate configurable burst numbers of line rate with configurable intergap between the bursts. The purpose of this test is to confirm and tune and validate the burst handling capabilities of the link. This block is very useful for buffer tuning and TCP windows optimization. Y1564, the rival. Y1564, aka or EtherSAM, this is a more advanced test focusing on CIR, EIR capabilities with various success and failure criteria. According to the ITU Y1564 standard, the test can support up to 16 simultaneous flows. Flows can be various destinations or different class of services or a combination of both. Y1564 success and failure criteria are packet loss, delay, and delay variation, as well as CIR and EIR per every flow or service being tested. The Y1564 can also run in a single direction, thus making it better test to verify services requiring one-way matrix compliance. Another great value in Y1564 is its ability to detect and verify the cost mismatch between source and destination, or even source and back to the source if it's a round trip. This is similar to what PAA of Accedian excels in. It is even better than TWAMP cost validation since TWAMP only compares sent versus receives at the source only. The Y1564 test flow is as follows. The test will start pushing up to 25% of the CIR. If there is a success, which means packet loss is okay, frame delay and delay variation are within the limits, the test will shift gear up to 50% of the CIR to be tested. Then if all goes well, it's gonna go up to 75% of the CIR and then to 100% of the CIR. If all goes well and EIR is to be tested, the test will push to CIR plus EIR. If all goes well and if the policing is enabled, the test will push up to CIR plus EIR plus a certain percentage. This is to confirm or to verify if the policing is working or not. If performance is enabled, the performance option, the test will repeat at CIR 100% only, but for a longer time. So this is like an endurance test. It can run from 1 minute up to a single day, 24 hours. If any service allows traffic beyond the CIR plus AIR plus the M factor, this means that the test will fail because this service or this circuit is too permissive. So if we enable the policing and the test will allow more than CIR plus AIR plus M factor, this means that the circuit is too permissive and it's a failure. So unlike the first impression people get, yes, if the traffic could exceed CIR plus AIR plus M, this means this is a failure. Traffic should have been dropped. M is a slight offset beyond the CIR plus AIR. While running the Y1564 test, there's a visual display on our elements and the VCX or sensor control, as well as the orchestrator screen, similar to the below. So you'll see here graphically the 25% progress, then 50, then 75, then 100, then CIR plus CIR. And if the policing is enabled, you'll also see a progress on the policing and then at the performance. The Y1564 output file is also with multiple blocks similar to the RFC2544. In this case, the blocks will be representing the services, the parallel services to be tested in the 1564 test. Here's a sample of the output file. So basically, if we were testing two services, you're gonna see description first of the service, and then the first service details, and then the details about 25% CIR, 50%, 75%, then 100% of the CIR. In this case, it was a 50 meg test. Then you will see also the delay variation, and there is no packet loss, so there's a success so far. CIR EIR, which is 5, so again, this is a pass. Then to the policing. The policing based on the calculation of the M factor, the test was pushing up to 68, and those 68 made it. This means that the circuit is permissive instead of being really policing the circuit. It's not policing the traffic, so this is a failure. So service 1 failed because it was too permissive. Service 2 also Again, the same, it could be a different destination or different class of service. The details of the CIR plus EIR, policing, again, it failed because it's too permissive. So there is two blocks for those two services, and there is the overall result, which is also a failure because those two services failed. If one of them failed, the overall will fail anyways. So this is how the Y1564 report works. So after covering the RFC 2544 and its rival, the Y1564, we're gonna make a quick summary between both to show the value of each. As mentioned earlier, each test has its own perspective of testing the conformance of the service or of the link. Below are some differences between both tests. For example, when it comes to speed of deployment, Y1564 can be a faster test to roll out because of its support for multiple destinations, up to eight destinations or 8 class of services, whereas the RFC 2544 support only 2 flows for the elements and 4 flows for the modules. So it's a kind of slower test to roll out. When it comes to the speed of the test setup itself to provision the test, RFC 2544 has 4 blocks to be provisioned, so it's a little bit slower in time versus the Y1564, which is a faster test to set up. Even if you have 8 flows, the setting up and adding the parameters and data entry for those tests for those flows is even faster. So overall, from a rollout perspective and setup perspective, the Y1564 is a faster test to set up and roll out. When it comes to testing a line rate of 10 gig, so a 10 gig circuit, whether from the elements perspective or from the sensors control, our modules, the RFC 2544 is a better test because it supports up to 1 gig or 10 gig out of the box. Y1564 doesn't support 10 gig per flow. We have to combine all the flows. So you have to utilize in parallel mode the 8 flows, each up to 1.25 gigs, so that we get a total of 10 gig. So if there's a 10 gig circuit to be tested, RFC 2544 is an easier way to do it. When it comes to burst testing, the Y1564 unfortunately does not have any capabilities for burst testing. CBS, EBS, buffering. Y1564 is not the test. On the other hand, RFC 2544 supports bursting due to the back-to-back block, which is the last block, the fourth block of the test. It has the power and the capabilities to do burst testing, which is also very helpful for TCP window tuning and buffer tuning. Again, when the scenario is or the challenge is testing against packet size, RFC 2544 has a more friendly and more conclusive report when it comes to the packet size versus the bandwidth reached. Y1564 has also emix mode and fixed packets mode where you can also test per packet size. However, the results are not as conclusive and friendly as the RFC test. When it comes to the acceptance criteria, RFC 2544 has only acceptance as packet loss, although it displays the delay and the jitter in its second block, but those are not acceptance or failure criteria, they are just reference. On the other hand, Y1564 has packet loss, delay, and jitter as acceptance criteria, and optionally it has the class of service mismatch as an acceptance criteria. So Y1564 is a better test when it comes to testing services with a wider expanded range of KPIs. When it comes to the direction of the test, RFC 2544 is a round trip test. So whether there is a bottleneck in the uplink or downlink, RFC cannot determine. On the other hand, Y1564 is a smarter test when it comes to single direction testing because it supports A to B versus B to A. This is the Accedian version of the Y1564, by the way. And last but not least, the end-to-end class of service validations. RFC 2544 has no means to validate and compare class of service between source and destination. However, on the other hand, the Y1564 support the detection of class of service changes between the source and destination if it's a single mode test, single direction mode test. And if it's a round trip mode test, it also support the mismatch validation of the DSCP or PBIT or VLAN between the source and back to the source itself. So whether it's a single direction trip or a round trip, Y1564 support the end-to-end class of service validation. This is a very powerful feature. So after covering the RFC 2544 and the Y1564 and covering the quick summary between both, it's time to shed some light about the Accedian version of SAT and the Accedian flavor of the SAT. From the earlier hardware portfolio to our current virtualized portfolio, SAT has always been one of the basic features in Accedian. So it has been always subjected to evolution, to bug fixes. It's been always a very valuable feature. RFC 2544 and the Y1564 are found in our 1G and 10G elements, as well as the 1G and 10G sensors, which are managed by the sensor control. So SAT can be utilized directly by connecting to the elements themselves or directly by connecting to the sensor control. And also SAT can be utilized by directly connecting to the orchestrator. And by connecting to the orchestrator, there are additional benefits that we could get, which we will not get by directly accessing to the elements and to the sensor control. For example, the birth certificate that we generate in the elements and sensor control is a text file or XML file, while under orchestrator it can be a PDF file showing a graphical representation of the results. That's very cool. Also, another option or added value by using orchestrator is that the generated birth certificate, the PDF file, can also have a customized logo embedded in the file. This means that the customer or the customer's customer can get a very tailored brand for him as a PDF birth certificate. Another point is that SAT under orchestrator saves a lot of time for the user because it will automatically set up a loopback at the peer end, and it will automatically remove the loopback after the test has been done. It's also a time saver and a very nice added value feature. And another point is that once SAT is being used under the orchestrator, the same saved profile can be reused and cloned and reused for other sources and other destinations. So this will help also standardize the SAT testing, and it will help also for a faster rollout. So since we're speaking about the Accedian flavor of SAT, it's also worth mentioning that the Accedian flavor of the RFC 2544 supports jumbo frames, whereas the standard does not suggest or imply that we should be using jumbo. It's a very useful feature for the operators. Also worth mentioning that the RFC 2544 can be also used in a different way, in which we can use it to simulate oversubscription between two endpoints. So customers who wish to plan for expansions or through marketing campaigns, they can simulate the impact of the extra traffic on their KPIs by using RFC 2544 from Accedian. So while the elements and the modules are already passing normal traffic, they can add on top of the additional traffic and offset traffic, and at the same time observe the impact on their measured KPIs. It's also a very useful feature. And again, speaking about the tips and the flavors of Accedian, when it comes to Y1564, it's worth mentioning that the Accedian Y1564 interop with all other vendors, no problem, except when it comes to the one-way Accedian measurement, one-way cost validation, one-way KPI validations, has to be Accedian to Accedian. It's also a very powerful feature for Accedian. So if there is a requirement to measure one-way direction, the KPIs, or one-way direction, the KPIs or the cost mismatches, it's only Accedian to Accedian that can achieve that. So it's also a very good, powerful feature for Accedian SAT. And now it's time for the use cases. In fact, I have selected one use case which is very useful, and it will really show the value of the RFC 2544 and the necessity of having this RFC 2544 before handing over to the live operation. In this case, we have Accedian RFC 2544 that was able to neutralize a conflict between our customer and his customer. So our customer's customer was complaining that he is not getting the purchased bandwidth, and our customer was using his tools to defend that he's providing the bandwidth. So he was using the old conventional tools, and for him everything was okay. So there was lots of finger pointing between the customer and the customer's customers, and things escalated really to the legal department. After Accedian came into the rescue and deploying the solution and running the RFC 2444, the results were very conclusive as below. The report, the birth certificate was generated, and as you see that while trying to test and push to the 25 megs of throughput, we see that the 64, 128, 256, and 512, so all the small packets, small to medium packets, were not reaching the 25 megs. They were only doing 10 megs. That's very strange. So the other part, or the bigger or larger packets, were okay. So what do we conclude? This explains, in fact, why both customer and the customer's customer, both of them were finger pointing. The customer was right, his bandwidth was not reachable, so the pain was there. And our customer, before using Accedian, thought he's also right because his test could not reveal the hidden problem. He was doing the usual test, choosing a packet size, which is probably the conventional 1500 or 1400, and he's doing the test and everything was okay. It was only until the RFC 2544 that put the end to this conflict by showing clearly that not all packets are reaching the desired bandwidth. This is very important. Smaller packets were failing to reach 25 megs, while the larger packets were okay. Had the customer used RFC 2544 at the first place with a proper birth certificate report, this conflict would have been avoided. After further investigations, the customer's customer found that it is the firewall, and it was resolved by applying a firmware upgrade. And problem was sorted and verified again by running another test, which showed everything is clear now and green. So this is a very interesting case in which we really came and utilized a conflict that was reaching the legal department of both, claiming for voucher return, claiming for end of contract, and penalizing them, and things was really escalating. Both parties were thinking that they're right. Accedian came in and helped with the RFC 2544, and as of then, they consider RFC 2544 as part of the provisioning and delivery. And this is the message we should carry and tell all our customers about the importance of RFC 2544 or Y1564 or SAT in general. If you do SAT properly as part of your workflow, the chances you have problems later are very slim to none. So, thank you for watching this video and have a good one.